So in this example, given the function f of x is equal to x to the fifth plus x cubed plus 2x squared minus 12x plus 8, we are asked to write it as the product of its linear factors, which is like where we'll have like, an example would be something like x plus 3, x minus 2, x plus 2i. That's a product of linear factors, so write it in that format. And we also are asked to list all of its zeros. Now take note here that we are asked to list all of its zeros, so we have to include both the real and complex numbers here. So the first thing we want to do is we want to try to figure out where we start. Where do we get our possible list of zeros from, our possible test points here. And for this, that's where we're going to look to our P and our Q. So we have some pretty easy coefficients here. So here we have a coefficient of 1 in front of our highest degree term there, and then we have 8. So because we're just going to be dividing by 1, we have a coefficient of 1, I can list my possible zeros as plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. From here, I really need to have some more guidance as to what numbers I should be looking at, which ones I should be testing first. And to do that, I'm going to go ahead and take a look at the graph. When I put that function into my graphing calculator, I can see two definite points where the graph is intersecting the x-axis, which is giving me my zeros. The first one is at -2, the second one is at +1. So those are going to be definite zeros. Since I was able to determine that one of my zeros was +1, I'm going to start off with that for my synthetic division process. So I'm going to start off and write 1, and then set up my synthetic division chart. Now, the terms of my polynomial are already listed from largest to smallest in terms of the degree, so that's good. However, I do need to make note here that I do not have an x to the fourth term, so I have to make sure I'm using a 0 placeholder when solving this problem. So when I start off, I have a coefficient of 1, a 0 for my x to the fourth, a 1 on my x cubed, a 2 on my x squared, a -12 on my x, and an 8 for my constant. So from here I can start to go ahead and do my synthetic division process. Remember, you start off by bringing down that first term and then multiplying. 1 times 1 is 1. And now we are adding. And remember, in long division you subtract these numbers. In synthetic division we are going to be adding these. So 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. 2 plus 2 is 4. 1 times 4 is 4. Watch your signs here. -12 plus 4 is a -8. 1 times -8 is -8. And 8 minus 8, or 8 plus a -8, is 0. Because I have a remainder equal to 0, I know that 1 checks out as a possible factor. I'm now going to take my quotient, this 1, 1, 2, 4, -8, and I'm going to use that for my next round of synthetic division. Remember, this translates into this. So what I'm left with is x to the fourth plus x to the third plus 2x squared plus 4x minus 8. So I'm going to use those coefficients from there and do the next part of my problem. For this, I'm going to use my other solution that we found here, which was a -2, and I'm going to use that for my next round of synthetic division. So for this one, rewriting what we have up here, I'm going to use a -2 and list all of my coefficients. 1 from the x to the fourth, 1 from the x to the third, 2 from my x squared, 4 from my x, and my constant -8. From here I bring down my +1, and now I'm multiplying and adding. -2 times 1 is -2, 1 plus a negative 2 is a negative 1. Multiply to get a positive 2, add to get a positive 4. Multiply to get a negative 8, add to get a negative 4. Multiply to get a positive 8, add to get a 0. Again, this checks out. When I get this remainder of 0, this means that negative 2 is a 0. So now I've confirmed that both negative 2 is a 0 and 1 is a 0. So now what I'm left with is I had a remainder of 0, and I'm left with this as my quotient. And I can rewrite this as a negative 4, 4x, negative 1x squared, and 1x to the third. I now need to continue to see if I can factor this. When I looked at my graph, remember there were no additional real value zeros there. So now I have to go back and say, can I factor this new polynomial that I have? And if I have x cubed minus x squared plus 4x minus 4, I'm going to try to factor this by grouping. When I do this, I end up getting a GCF of my first term, or my first set of parentheses here, is going to be an x squared times x minus 1 plus 4 times x minus 1. So there is a GCF of x minus 1 here, so this can be rewritten as the product of x minus 1 times x squared plus 4. So what this does is this shows me my 2 other factors, or in this case my 3 other factors actually. This right here, if I was to set these all equal to 0, I get an x minus 1 is equal to 0, so I get another x equals 1. These are, remember, called repeating zeros. Since I've already solved above and shown that x equals 1 is one of my zeros. If I take a look at the second part of this, and I set x squared plus 4 equal to 0, and I solve this, I get x squared is equal to a negative 4. Square root both sides, look at the negative inside the radical, convert that to an I, and get that x is equal to plus or minus 2i. Remember, complex roots always come in pairs. You always must include both the positive and the negative. So as of right now, we have our 5 roots. We have our 5 zeros. We have the first one that we have found. We have the second one we found. We have a negative 2, we have a 2i, and a negative 2i. And going back to the fundamental theorem of algebra, remember our highest termed power, the degree of the polynomial that we were just solving, was an x to the 5th, which would imply that we should have 5 roots here. And if we look at this and we count them, we have 1, 2, 3, 4, 5 solutions. My next step that the problem asks me to do is write it as a product of its linear factors. To do this, the most important thing here is to watch your signs. So to take my zeros, I can now write the original polynomial as the product of its linear factors like this, by stating that f of x is equal to x minus 1 times x minus 1 times x plus 2 times x minus 2i times x plus 2i.